Hello everyone, welcome to my YouTube channel Easy Programming. I'm Naveen Mishra. Let's continue our series of Java programming. In this video tutorial, I will cover an important topic of interprocess communication in threads and synchronization keyword. Before you guys start this video, please do watch my previous video of thread lifecycle and multi-threading. Only then you will be able to understand that topic. Okay, so let's start with today's video. Interprocess communication. So what is interprocess communication? Till now, in the previous video lecture, I have explained you about threads, how they work. It was like we have three threads: A thread, B thread, and C thread. Okay, so let's name it A. This is B, and this is C. And in main thread, I was just connecting these all. I was just calling these threads using the start method. What I was doing, I was calling the start method. When these threads were working, when A was working within itself. It is not utilizing anything outside itself, that is A. When B was working, was working within itself and was not using any other resource outside the B, and same as C. Okay, so what I'm trying to tell you is they are using their own resource, they were working in their own workspace. But sometimes there will be a situation when they compete for the same resource. That is, let's say there is a account, okay, whose value A want to assess for a write purpose and B wants to assess for a read purpose. Now since both the threads A and B are competing for the same resource, that is account value, so this is called inter-thread communication, when they work within themselves, when they work to get some common values, common resource. Okay, so let's continue. So before that, ABC were called the independent threads because the threads are working within themselves. They do not create any internal problem. But there will be cases where the threads may share the common data or compete for the same resource. Just I have given you the example of accounts. In such cases, interprocess communication may lead to inconsistent results or deadlock. I will explain these two situations in this video. Okay, so generally when two or more than two processes are competing for similar resources, then they may lead to incorrect results or deadlock situations. To overcome this problem, we have to understand the concept of interprocess communication and how to use the synchronized keyword. Okay, first, now what is a resource? I have explained you in the example that account is a resource. What is the definition of resource? Simply, it can be a hardware, it can be a software, or it can be a small piece of information. For example, your A thread wants to print something in the printer, then printer becomes a resource, which is a hardware resource. Let's say there is a file which is a TXT format, which A and B threads want to access, then this becomes a resource, a software resource, or a simple piece of information like a value, an amount of 5,000 or 10,000. Okay, so these will be called your resources. Okay, so I'll explain how the interprocess communication works with an example. So let's see an example. Suppose we have two bank accounts, one bank account named A and one bank account named B. Bank account A have a balance of $5,000 and bank account B have a balance of $2,000. Now let's say I want to run two transactions. The first transaction, process P1, I will call a process, you can say a thread, which simply wants to perform two tasks. First of all, it wants to assess the balance of A and then subtract 500 from it. You see here. Then it wants to add the same value in the account B, that is 2000 plus 5, 2500. So we have a process or a thread P1. We have two resources A and B, and process P1 wants to assess the value of both these resources, account A and account B. Okay, Then we have another transaction, other process or other thread which just want to read the balance of both these accounts and then add these values. Let's say P2 runs and reads the value of A resource 5000 and B resource 2000 and adds this value to get the result, that is 7000. So we have two processes or two threads. We have two processes or two threads. You can say this is your thread T1, you can say this is your thread T2, and they are competing for the resource, these which can be called resource R1 and resource R2. Now T1 also needs both these resources and T2 also needs both these two resources. Okay, now in this scenario, if both P1 and P2 are threads, then they are competing for the same thing I have explained. I have written it here. Now let's say they run sequentially. So first of all, P1 executes followed by P2. Then the result of P2 will be, so this walk will be done. This walk will be done by the P1 resource. So the balance will become 4500. Then plus 500, this task will also be completed. The balance will be 2500. And then P2 runs. So the add A and B will result $7,000. So if P1 executes first followed by P2, then P2 should produce the result of 7000, that is A's balance 4500 plus B's balance 2500 will be added to get the result 7000. Okay, now if the sequence changes, let's say P2 executes first and then P2. So P2 assesses these values first and will get the values of 5000 and 2000, you see here. And again, if it adds this value, the result will be $7,000. So right now the sequence doesn't matter. If P1 executes first then P2, the result is same. If P2 executes first and then P1 executes, then the result is same. But in threads we have learned that the processes or the threads can be left in between and continued later on. Now this can create a problem. Let's see. The first problem is inconsistency and the second problem is deadlock. But first of all, we'll study about inconsistency. So let's see where the inconsistency will come. So again, we are to the example. We have two accounts A and B with balances of $5,000 and $2,000, which will be called resource R1 and resource 2. Here is the problem. We should write 2 here. Sorry for that. So let's continue. So resource 1 and resource 2, account A, account B with balance of $5,000 and $2,000. Let's say process P1 starts first. It reads the value of A, subtracts 500 from the A and want to continue, but in between it is left and P2 starts. P2 reads the value of A, which is 4500 now because this task have been completed, and then it reads the value of B, which is 2000. Then add both these values, the result is 6500. Once P2 is done, then P1 completes its missing execution and performs the operation on B, that is add the value of 500 in B. There is a problem, there should be plus. Okay, so it reads and add this value this. So after P1 the transaction should be 4500 here and 2500 here, but since this transaction executes, it performs this task, and before doing this task is executed, which gives you these two balances sum, which is 6500, which is definitely an incorrect value. Okay, so this is an inconsistency, that is the sequence of threads execution are not producing the accurate result, which is called an inconsistency. Now the problem of inconsistency can be solved using the concept of locks. Okay, so just like we apply lock to our important assets, similarly whenever a process will execute and whatever resource it needs, it must lock it first. Okay, now there are some rules of locking. All the processes, all the resources can have lock, and a lock and a resource can have only two values regarding the lock. One is locked status and another is unlocked status. Okay, so let's understand this first. So let's say this is my resource R1. This is my resource R1 and this is my resource R2. Okay, P1 thread wants to execute. It needs R1 and R2. It must apply the lock to both these resources. So it should lock R1 and it should lock R2. Only then it can continue with its execution. This is a simple concept of locks. Okay, so there are some rules of locking and how to use the locks. So these are the rules. Any process can request for lock, that is P1, P2, P3, P4, whatever process can request for a resource, you can request a lock. If the resource is available and is not being used by some other process, then the request is accepted and process locks the resource. But if it is being used, then the requesting process enters in the wait state. Locked resource can only be used by the process who locked it. So for example, P1 locks resource R1, then only P1 can use this resource R1 and no other process can use this resource R1. Okay. Lock must be applied before the start of process. You cannot request for lock in between. You cannot request for lock after the execution. You have to apply for lock before starting your execution at the beginning. Okay, and once you are done, once you have completed your request, once you have completed your execution, you must free that resource. So there are some rules of locks that you must remember. Only then you can understand the concept. Now theoretical locks in Java are implemented using the concept of synchronized keyword. I will write the program for synchronized keyword in this video, but let's continue with theoretical work first. Let's understand if the inconsistency is removed by the locks or not. So let's start again. Two resources A and B, balance is $5,000 and $2,000. P1 starts first and requests for resource account A, resource 1A. Since it is not being used by any other process, the request is granted. So it continues further and request for another resource, another process account B. Okay, again account B is not being used by anywhere else, so it is locked. In between, P2 executes and asks for resource A. Now A is locked, so P2 enters in wait state. Okay, so P2 is not executing. After getting the locks A and B, process P1 perform both the operations, that is subtracting 500 from A and adding 500 to B. Once the task is complete, till then, since P2 requested for the resource A, which is being held by the process P1, P2 enters in wait state. P2 is not executing. Once the task is completed, process P1 unlocks both these resources. As soon as P2 sees that both the resources are unlocked, it reads their value, it locks them, reads their value and shows you the balance. So here inconsistency is removed. I hope you guys have understood it. Okay, I will explain it again. So first this process executes, A is locked. Then B request for this process, this is also locked. P2, just a second, P2 request for this, P2 request for this, since it is locked, it enters in wait state. It cannot execute. Once the task is completed and the resources are unlocked, it reads the value, it locks both these resources and does the task. So there are no incorrect results using the concept of locks. Okay, but the concept of synchronized keyword or the locks produces another issue which is called a deadlock. Let's understand this. What is a deadlock? If two processes are executing for the same resource and waiting for some resource which is held by some other process, thus no process can complete its execution, then it is called deadlock. Okay, so let me give you an example. So I have two processes, P1 and P2, and I have two resource R1 and R2. Process P1 request for R1. It requests, but it is given to P2. P2 has locked it. Okay, P2 request for R2. It again requests, but P2 is locked by P1 lock. So P1 is holding the resource R2 and P2 is holding the resource R1. P1 requests R1 but cannot get it, and P2 requests R2 but cannot get it because it is locked by P1. So neither P2 can complete its execution, neither P1 can complete its execution. Both are waiting. This wait will never end, which will result in deadlock. Okay. So this is the deadlock. I have explained it. Deadlock occurs when multiple threads need the same locks but obtain them in different order. Like P1 locks R1 and P2 locks R2, different order. Okay. So the synchronized keyword may give you an issue named as deadlock. Now let's see in our example that how the deadlock will occur. So again, we have two resources A and B with the balances of $5,000 and $2,000. Process P1 start first, requests for A and locks it. So right now P1 reads this value and put a lock in it. It is locked. Okay. Then P2 starts. P2 reads the value of B, wants to read the value of B, requests for lock B and applies it. So it assesses this value and locks it. Okay. Now P1 is holding the resource A and P2 is holding the resource B. P1 requests for B, but B is held by P2, so it enters in wait state. P2 requests for resource A, but it is held by P1, so P1 enters in wait state, and this wait state will never end. So I'll change it with different colors. Blue is for P1. Okay, so P1 request for the resource and locks it. Okay, then P2 executes P2 executes requests for R1 and locks it. Now it needs this resource, but P2 needs this resource. Both are waiting for each other to complete its task, but no one will be able to complete the task and there will be an issue. Okay, so I hope you guys have understood the concept of deadlocks. Now let's see the working example of synchronization. So what I'll do is I'll write a program in which what I'll try to do, I will create a bank account with a balance of, let's say, 5,000 or any amount $. I will create two methods. One will be of withdraw, another will be of deposit. Both these methods will be synchronized. Okay, withdraw, if the balance is less than the required amount, it enters in wait state and waits for deposit. Deposit, when receives the balance, receives the new deposit amount, adds it to the total balance and then calls the withdraw method, and then withdraw method completes. Okay, so I'll try to do that. Okay, in the main method I will create two threads and will assess the same resource, which is $5,000 balance. Okay, so let me show you how to do it. So I'll create open NetBeans. I'll create a new package here will be of synchronized and deadlock. So I'll create a new class here. The name will be bank, and I'll create a balance, double balance equals to, let's say, 10,000 rupees. And I'll create a method synchronized void withdraw money and amount. If balance is less than amount, then I'll give a message system.out.println balance equals to plus balance value will be printed plus amount to be withdrawn plus amount plus not enough balance waiting for deposit. Okay, and once I have this value, I will implement a try catch and put it in a wait state. Okay, so let's do that. Sorry. Try wait state. Since it can raise an issue, so I have to catch. I'll use the exception class. I don't remember what kind of exception it can raise. I think that is enough. Yes, it will work. So let's create another method synchronized void deposit money int amount, and we'll simply say system.out.println deposit working, and I'll say balance equals to balance plus amount, and I'll show you the new balance. Deposit completed, deposit amount plus amount plus new balance plus balance, and I'll use the notify method so that withdraw money can execute. Okay, so that's it. Bank account is created. So I'll create a new class, okay, for inter-thread communication. So I'll just right click it, Java class inter-thread. I'll create a main function here. And I'll create the object of bank class. I'll create a class or a thread, name will be thread withdraw, extends thread, so it becomes a thread now. It needs a run method, so I'll place a run method here, and I'll simply call b1.withdraw money, and the amount will be, let's say, 15,000. We know we don't have this balance. Okay, so it will call the other method. Okay, so I'll create its object thread withdraw tw equals to new thread withdraw, and I'll call tw dot start this thread. I'll repeat this for deposit as well. These are the inner classes. 5,000 to it. Okay, and I'll create it subject. And I'll call this start method. Okay, I hope my program will work. Let's see. I'll just run this file. Okay, I think I have made a mistake. Okay, deposit money is called. I think I have given some wrong messages. Why this message is not working? Okay, should have placed less than amount here. Okay, so let's run this file one more time. Okay, so there you go. First of all, withdraw money is working, and balance is 10,000. So this is working. Amount to be withdrawn is 15,000. Not enough balance, waiting for deposit, and it enters in the wait state. And then we came back here and executed this thread, which is deposit money. So deposit starts working. Deposit adds 5,000 in the current balance. Here the balance, new balance is 15,000, and then it should work and it should give me a message, withdraw complete. So I have to add one more line, system.out balance meets the required amount plus withdraw complete. Okay, so let me execute this one more time. So there you go, you see this withdraw also works. So withdraw starts first. Since the balance is not enough, it enters in wait state. Then deposit works, adds the new value, new amount, balance is complete. Then it notify the withdraw method. Withdraw method sees the balance is equals to the required amount. It matches and it executes. So I hope you guys have understood this program as well as this tutorial. So that's it from this video. Thank you very much. Please do subscribe and share to my channel and share my videos with your friends. Thank you very much. See you in the next video. Cheers.